Okay, we're now going to look at valence electrons. And valence electrons are the ones that determine what the properties of those elements are going to be like. Those are the ones that are going to be involved in bonding, when we're going to talk about later in this chapter. And so when we look at those valence electrons, those are the ones in that outside energy level, the highest energy level. So if we look at the electron configuration for an element like phosphorus, it's written out down here, and in red that's highlighted, that's the outer energy level because the 3 and the 3 tell you the energy level, and 3 is bigger than the other ones. So the number of electrons is the 2 and the 3 together, and that would be a total of 5 valence electrons. So if we look at column 1, everything in column 1 is going to have 1 valence electron. Everything in column 2 is going to have 2 valence electrons. Everything in column 3 would have 3, and so forth until you get to 8. And when we talk about columns or group numbers, we're talking about the main group elements. So when we look at our periodic table, those would be the 2 parts that stick up on either side. We're not looking at any of the transition elements. And 8 is the maximum number of valence electrons that we can have, with the exception of helium. Helium only has 2 valence electrons. So the group number is going to tell you the number of valence electrons. So it says to identify the number of valence electrons for each of the following. So pause the video, see if you can answer each one of those, and then come back. Okay, so for oxygen, if we look on the periodic table, it's going to be in group 6, so it would have 6 valence electrons. Aluminum is going to be in group 3, or column 13, and that would have 3 valence electrons. Chlorine is going to be in the main group of group 7, so it would have 7 valence electrons. Okay, now they're going to give it to me in terms of electron configurations. So again, pause the video and see if you can figure those out. So in this one, if we look at the part that's in red, 2 plus 1 is 3 valence electrons. The part that's in red right here is telling me the highest valence electron. So 3 is the highest energy level, and it has 2 valence electrons. In this one, 2 is the highest energy level because 2 is the biggest coefficient, and 2 plus 5 is a total of 7 valence electrons. Okay, now we're going to use the number of valence electrons to write what's called an electron-dot symbol. And the electron dot is going to tell me how many valence electrons that I have. So it's a quick, easy representation. Okay, and magnesium is going to be in column 2, so it would have 2 dots. And those 2 dots are usually written one on either side. Okay, so if we look at group 1, to group 4, we're going to use single dots. So sodium is in column 1 and have 1 dot, magnesium has 2, aluminum has 3, carbon has 4. So we have single dots. Now, once you get to group 5 and you're talking about 5 valence electrons up to 7, then once we've filled up 1 dot on each side, like you could think about this as being the 4 sides of a square. Once we've filled up 4, then we have to go back through and add a pair. And then oxygen has 6, so we're going to have 1 on each side. So for example, you would have 1, 2, 3, 4, and then you need 5, 6. And it doesn't really matter which 2 sides you have the pair on, as long as 2 of them are paired off and 2 of them are single. Okay, in the case of chlorine, I need to have 7, so I do 1, 2, 3, 4, 5, 6, 7. All right, and if we get to column 8, 8 is going to have everything paired up because there's 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. All right, now anything within that column is all going to be the same. So for example, in column 2, they all have 2 dots, and it doesn't matter what element you pick in column 2, they're all the same. So when we talk about the group number, that's the same for that entire column.